Alrighty, y'all. Today we're taking a look at question 3 for homework 5. And for this one, we're trying to find the resultant magnitude of the magnetic field 20 centimeters above a horizontal straight wire that is in a magnetic field. All right, so our wire going here has a current going left to right, 20 amps. And our uniform magnetic field is going straight down, right, with our 4 times 10 to the negative 5th Teslas. Right, and we're looking for the magnetic field at some random point, 20 centimeters or 0.2 meters above the wire. Right, so all we have to do for this one, right, the magnetic field at that point is going to be whatever this magnetic field is going straight down, added with the magnetic field as caused by the wire. So let's just find the magnetic field caused by the wire, which is the equation that we're very familiar with. Our magnetic field is our mu naught times our current over 2 pi r, r just being our distance between them, given with our 0.2 meters. Our current is also given. We have our B equals, again, our mu naught, 4 pi times 10 to the negative 7. Right? The 4 pi is going to cancel with, partially cancel with the 2 pi. So it's going to be 2 times 10 to the negative 7 times the current, given 20 amps, divided by our radius, which is our 0.2 meters. Right? So we have our magnitude of the magnetic field. But if we do our right-hand rule, with our current going to the right like that, our magnetic field around this wire is going to be kind of looping around like that. It's kind of hard to draw in 3 dimensions, but it's like on the bottom it loops behind, and so on the top it's going to be coming straight out of the page, right? Kind of like that. And it's going to be going straight into the page down here. So if we're trying to find our magnitude, right, this is going in the downwards direction. This is going, and whatever this is going in the outwards direction. They're going to be perpendicular. So again, to find our magnitude, we're just going to do our, whatever our B is, squared, plus our 4 times 10 to the negative 5th squared, take the square root, that's going to give us our B total. Right? Now question 4. Right? For this one, we're determining the magnitude of a magnetic field in the center of a loop. Right? So this one, we have a fun new equation that we get to use. Right? Our magnetic field equals our mu naught Ni over 2r. Ooh, that is a nasty looking R. Right? Right? And this N here. Oh, I'm sorry, I wrote the wrong N. Capital N. This N is our number of loops. Because our lowercase n for like a coil, that's our number of loops per unit length. Right? So now we can plug in the information that we know here. Right? So again, our mu naught, it's not going to cancel down the same way that it did before. But again, our 4 pi times 10 to the negative 7th is going to become 2 pi times 10 to the negative 7th. So that's our 2 pi. Right? Our number of loops, we're given that there's 20 turns. Right? That's how many times it turns around. That's how many loops it's doing. Right? Our current through the wire, 0.5 amps. And still in base units, so that's fine. Right? And then 9 centimeters, we divide by our radius, 9 centimeters. Again, base units, 0.09 meters. Right? And we evaluate that out. That's going to give us the magnetic field at the center of the loop. It's going to give it in Teslas because, again, we took everything into base units. All right. So I hope you found this video at least a little bit helpful. Let me know if you have any more questions about either of the problems that I just did. or any other problems that you want me to explain, and I will do my best to try to explain it, because I guess Sydney explains stuff.